42.5.
And then do we just subtract 7.5 from that number?
The 50, yes.
No, like for the next time, the 42.5.
Oh, for the next one, you still have our frac, every 10-minute period, given the way I set up the problem, you're gonna lose a quarter of whatever temperature you could lose. So that would be equal to the next 10 minutes. The most you could possibly lose is 22.5. And so delta T is whatever, 5.75?
5.625.
5.65, right. And so minus 5.6. So 36.85 for the next round, after the next 10-minute period. All right, so questions to hear?
Why did you put 22.5 on there? You just dropped it to 30.
So, because we're at 42.5 at this point, and the most, again, we're working on the assumption the temperature of the room is not changing.
Okay.
So the most it could lose is 22.5. All right. About the sort of shift into other implications of putting energy into a system. So, any other questions before I erase this? So when I was in elementary school, I was taught this next thing, none of the math, just the concept of it. Really excited to try it at home. So opening a glass jar with a metal top, and you put it under hot water, makes it easier to open. Why?
The temperature differences? The temperature differences?
Yeah, there is a temperature difference between the hot water and the top. What happens to the top? Why is it easier to open? It's more than just the temperature difference.
The lid expands. The lid expands.
The lid expands. Yeah, the temperature difference I don't think is enough to cause a. Ouch, actually, how would that work? Actually, if you ran the hot water over it just right and create a drop in pressure on the outside, it would probably make it harder to open because the lid would be pulled towards it and you increase the friction. I wonder if you could do it enough to make the actual notice. All right, anyway. So you put temperature, you put energy into a metal and the metal will expand. You put it into or you take it out of it, it will shrink. And the next bit I'm doing is because I was actually on a job interview for a summer job when I was in college, and I was asked this question, so I'm going to pose it to you. Upon what does the change in length depend? What would you guess? If I wanted to figure out how much does, if I have, I got an aluminum track sitting right here in front of me. If I heated it up, what is going to affect how much it will expand?
Changing the heat of the metal.
Ooh, let's work on the wording there. What do you mean? You said changing the heat, right?
Right, so when you pour the hot water on it, the metal heats up and it gets bigger.
Okay, yeah, so change in temperature.
Okay.
All right, so it does depend upon change in temperature. That one I remembered in my job interview. There was one I forgot. So it definitely does depend upon the change in temperature, and the change in temperature does depend upon the amount of energy you put into it. What else is going to affect how much this will expand?
Specific heat?
Indirectly, this will affect change in temperature because of the specific heat, which then will affect change in length. So indirectly, yes, we already have a change in temperature. What else is going to affect how much it will expand or shrink, depends on if temperature goes up or down.
The shape of the object?
Sid?
The shape of the object?
Actually, yes, it will affect that. I'm just going to assume it's something long and skinny for this. Generally, if it's long and skinny, we just worry about changing length in one direction. If it's a cube, it will expand in all directions, completely agree. But we'll just stick with delta L for right now, just length in one direction.
Mass?
Not the mass actually is incorporated into this part right here.
Could it have something to do with what it's laying on? Like the surface?
I was not considering that, but I think in fact it would. It doesn't show up in the formula because it's assumed that the energy you're putting into it goes only into that thing. But if you want to bring reality into life, yeah, you're right. But for right now, let's just assume it's on some insulating material that is not going to change temperature. I think, and going back to, I was thinking that Manal said, or maybe he didn't.
Is the object like closed or open? Is it hollow, or is it hollow inside the object, or is it closed?
Picturing solid. If it's open like that, if it's hollow on the inside, it will actually expand. Actually, he has a problem concerning that. Overall, the thing would expand.
Does it have something inside?
We assume that let's assume it's a solid material, all the same metal.
The type of metal?
Okay, yeah. It does depend upon what type of metal it is. And so this is known as the expansion coefficient. And you now have covered the two things that I got in the job interview, and you've left off the one that I left off. I guess it's like in the collision, the fact that the time that two things touch each other is the same is one of those things that when I think about it, I go, oh, of course, but could not at that moment. So let's say I heat up this track here, or I forget the track. I have a piece of aluminum, an aluminum rod. I heat it up and it expands a centimeter. Is that significant?
Yes. Yes.
Why do you think this expansion of a centimeter is significant?
Because it's a change from its original form.
So if we were in one of the buildings downtown, which generally, let's assume one of the tall ones, so we got metal in it, a hot day, it does expand some. Would a centimeter be significant in that case?
No.
Why not?
Because you wouldn't be able to tell you wouldn't be able to notice a change, I guess.
So what is the other factor that,
Size, area,
length?
oh,
If we're dealing with three-dimensional, then it's volume. If we're dealing with a two-dimensional surface, then it would be surface area. That's the one that I couldn't remember during the interview.
how would length be in the formula?
Because the change in length does depend on how long it is to begin with.
Oh, okay.
You know, expanding a centimeter may or may not be significant depending on what the original size is. So if we were dealing with aluminum, which I have right here, which I have right here, there we go. So alpha for aluminum is 24 times 10 to the negative 6 per degree Celsius. There are no units on top. It's a factor for each degree Celsius. So if I have an aluminum, so 3.0864, this number comes from an earlier part of this exercise, which I'm skipping over right now. So let's say the original length is this. I heat it from 20 degrees Celsius to 60 degrees Celsius. How much does it expand? Well, straight plug and chug. The amount that the length changes is alpha, which is 24 times 10 to the negative 6 per degree Celsius, times the additional length, 3.0864 meters, times change in temperature, 40 degrees Celsius.
.00297
Units?
meters.
So if we had an aluminum rod that basically went from the floor to the ceiling and you heated it up from room temperature up to 60 degrees Celsius, that thing's going to expand a little under 3 millimeters. So about like that. That's how much it's going to expand. It is not particularly significant, fortunately, otherwise building tall structures would be a real huge nuisance. But it is something you do need to take into account, especially bridges where you've got the gap there and you've got the metal, when your car goes over it, you hear the boom. That's there to account for the expansion. It's just going to shrink in wintertime, it's going to expand in summertime. You don't want it butted up against itself. You don't want just one solid piece of concrete. You got to have the grooves in it because otherwise you start getting the buckling, because when it expands, it has nowhere to go but up. And so that's why there are grooves in the sidewalk and grooves on pretty much anything that's concrete. Or gaps if it's metal. And with that, have a nice Veterans Day.
Do we have class Wednesday?
We do not have class on Wednesday. I feel like when I said that came across as angry. No, we don't have class on Wednesday. How about that?
I wasn't sure. It's in my other class, and I was like,
Or the college is closed. Now, if you're doing an online class,